Attention. Today the first thing that we're going to learn is we're going to learn how to, in a few minutes, we're going to learn how to rewrite exponential functions into logarithmic functions and vice versa. Okay, what I'm about to do is pretty easy. You just have to pay attention because if you don't pay attention, it'll be like a foreign language. If you pay attention, it'll be easy. We know that exponential functions are in the form y equals a times b to the x. But if a is 1, you don't have to write it. Logarithmic functions are in the form log base b of y equals x. So this first one, what would the 2 be? The b value, right. What would the 5 be? The x. And what would the 32 be? The y. Does everybody understand why 2 is b, 5 is x, and 32 is y? Because it's in the form y equals b to the x power. So to rewrite that in log form, you'll start by writing the word log. Your base is 2, so now we write that as the base. Your y value is 32, and then it equals the x value, which is 5. Now, you can also check to make sure you did it right. Watch how I can check this. If I go to math, and then I go to log base, which we learned the other day when we were graphing these, and I type in 2 in the base, and then 32 inside parentheses, on my paper, I say that this equals 5. Let's see if the calculator confirms that. It does. That means we rearranged it correctly. It still makes sense mathematically. Okay, now let me show you something else. In my opinion, the way I just did it is the harder way. Like trying to say, okay, well that's the b, so it's going to go over here now. This is the x, so it'll go right here. This is the way I've always remembered to do it. If you're trying to write it in log form, the most obvious thing is you write the word log. Okay? Then after that, 5 is first, right? It will stay first. It will just drop down as the base. 3 and 125 will just switch sides. So 125 goes over there, 3 goes over there. Okay? 5 stayed first, and these two just switch sides. And then you can check it. Just type in log base 5 of 125 and make sure it says 3. So I'll just copy and paste. Log base 5 of 125. And it says it equals 3, just like we said it does on our paper. So that means we did it right. It must be. Okay, so for this next one, if you go by the pattern I just told you, you'll write log, because we're changing it to log form. 2 is first, so it stays first. It just drops down as the base. X and y just switch sides, so y equals x. Now, on something like that, you're not going to be able to type it in the calculator and check it because it's y and x. It's not numbers. But anytime everything's numbers, you can always type it in and check it. So let's look at number 4. Log base what? Of equals 2. That's one you could check. You would literally just type in log base 7 of 49 and make sure the calculator says 2. Okay, now we're going to learn the other way around. Now I'm going to change it from log form back to exponential. You can follow the same pattern that I just did. 2 is first, right? So it's going to stay first. 8 and 3 switch places, but when they do, 3 becomes the exponent, and then 8 just goes over there. And doesn't that make sense? Isn't 2 cubed really equal to 8? 2 times 2 times 2 is 8. So when we change number 6 to exponential form, 6 is first, so it stays first. 3 and 2/16 switch places, but 3 becomes the exponent, and then 2/16 is what it's equal to. And is that a true statement? Is 6 cubed 2/16? Yeah, 6 times 6 is 36, and then 36 times 6 is 2/16. Number 7, it'll be 3 to the what power equals y. So that's not one you can check. And then number 8, what's different about number 8? So if there's no visible base, what is it? 10. It's always 10 if there's no visible base. So won't this be 10 to the third power equals 1,000? Is that a true statement? Is 10 times 10 times 10 1,000? Okay, so for the next few minutes, I want you to flip to page 18 and try that page on your own, and then we're going to move on. Back on. So, nobody has any questions off of this page? 6, 7, and 8? All right, number 6. You're obviously going to write it in log form because it's currently an exponential. So, log base 2 of 1 over 8 equals negative 3. And then remember, this is all numbers, so you could check that in the calculator. You would just type in log base 2, and then 1 divided by 8 inside the parentheses, and when you hit equals, it'll say negative 3. Okay, number 7. Log base of equals, right. All you're doing every time is this number's first, so it stays first. These two numbers switch sides. So the 8 comes over here, the 3/4 goes over there, every time. But you can always check it by typing it in and making sure that when you type in log base 16 of 8, make sure the calculator really says 3/4. Any other questions? Okay, now we're going to skip. Yeah, this is going to be on Friday's portion. That's why we skipped to it. Okay, so now we need to skip to this page, which is 22. Okay, I'm about to give you a few notes, so you might want to get out some notebook paper to write this down if you don't think you can squeeze it in on this page. It's going to be these 3 things. That's fine. So if you think you can squeeze it in, like down here where there's like a space. But if not, you might want to get out notebook paper. Okay. So, the first property we're going to talk about today is the product property of logarithms. It says that if log base A of u times v, that's condensed form, and if you're asked to expand it, this will be on Friday's portion of the test, yes. So, this is known as condensed form, okay, condensed. If you're asked to expand it, you will write log base A of u plus log base A of v. That's expanded form. Okay, so if in condensed form it's a product, which means that they're being multiplied, when you write it out in expanded form, you put a plus sign between them. So let's do an actual example with numbers so that it makes more sense. Okay, so say you have log base 3 of 4 times 2. That's known as condensed form. If you're asked to expand it, you would write log base 3 of 4 plus log base 3 of 2. You have to write the word log twice, once to represent the 4 and another time to represent the 2, and then both of them are base 3. Since it was multiplication in condensed form and expanded form, you add them. Now, even these kind can be checked. Watch how I would check it. First, I'm going to type in what I see on the left. So, log base, I'm just going to copy one instead of redoing it. Okay, so my base is 3, so I'm going to cover up that little 5 with a 3. And then inside parentheses, I'm going to put 4 times 2, or honestly, you could just go ahead and put an 8. It doesn't really matter. Okay, so look, does everybody see that all I'm doing right now on the calculator is typing in log base 3 of 4 times 2? And when I hit enter, I get 1.89. Now I'm going to type in what I see in expanded form. So log base, hold on, math, and then it's all the way at the bottom. Log base 3 of 4, shh, pay attention, plus, I have to hit log base again, 3 of 2. And when I hit enter, I get 1.89, just like I did when I typed it in condensed form. So that's how you can check it to make sure you've expanded it correctly. Okay, so that's known as the product property of logarithms. Now, of course, we're going to talk about the quotient property of logarithms. If you have log base A of u divided by v, that's condensed form. So if you're asked to expand it, it'll be log base A of u. And then what sign do you think I'm going to use? Guys, if multiplication turned into addition, this is going to turn into subtraction. Log base A of v. That's what the quotient property says. It says that when you have a quotient and you're asked to expand it, you subtract them. You have to write log twice, once to represent the u and another time to represent the v, and then both of them are base A. So now let's do an example like that. If I have log base 5 of 10 divided by 4. In expanded form, that will be log base 5 of 10 minus log base 5 of 4. And then I'm not going to do it just to save time, but if I wanted to, I could type in this side, see what it is as a decimal, then type in this side, make sure I get the same decimal, and then you'll know you did it right. Any questions so far? Okay, there's one more rule that we're going to learn. The last rule is known as the power property. It says that if you have log base A of u to the n power in condensed form, and you're asked to expand it, you'll bring the n down in front as a coefficient in front of the word log base A of u. That's all you have to do for the power property is bring the exponent down to the front. So an example of that would be if you have like log base 7 of 5 to the third power. In expanded form, it would be 3 log base 7 of 5. Okay, and you can also type in those. Type in this one in the calculator, and then type it in this way in the calculator. Shh. Are y'all ready? Okay, so those are the 3 properties. So number 1, what property are we dealing with? The power property. What does it say to do with the power when you're expanding it? You take the exponent to the front, so that 5 will come down in front as the coefficient, and then everything else will stay the same. Okay, and since everything up there is a number, you could type in this side, see what decimal it is, type in this side, make sure it matches, and then you'll know you expanded correctly. Okay, what property are we talking about with number 2? Product, because they're being multiplied, right? So when you expand it, it'll be log base 2 of 7 plus, because whenever it was a product, over here you add log base 2 of 3. Okay, what rule are we talking about for 3? Quotient. So log base, what is that, base 5 of 19 minus, because if it's a quotient in condensed form and expanded is subtraction, log base 5 of 2. And any of these so far, you can type in both sides and check them. Number 4, what property are we dealing with? Product. So what will the expanded form look like? Right, log base 2 of 6 plus log base 2 of 8. Okay, number 5, what property are we talking about? Product again. So what will the expanded version look like? Correct? If it's a quotient like number 6. So for number 6, that's a quotient because A is divided by 3. So when you expand it, what is that base? 5 of A minus log base 5 of 3. Now, when you get to problems like that in number 5, you're not going to be able to check them because you have variables, okay, that you can't type in. Number 7, what would this one look like in expanded form? Right. And make sure you don't do like me and make it look like a 35. Make sure you write this number way bigger than your base, and then plus log base 3 of y. Number 8, what property are we dealing with, Orlando? You got somewhere to be? Power. What do you do when there's a power and you're asked to expand it? Yeah. See why you shouldn't pack up till I tell you? You bring the 10. Yeah. Of A. All you do is bring the power down to the front. So it'll be 10 log base 3 of A. Tomorrow we will continue on this, so there's no homework. I always give you plenty of time to switch out, so there's no reason to pack up before I say so.